Hi, I'm Teacher Thomas. Welcome to A-Level Maths. This is 9231 Further Probability and Statistics, Topic 3, Chi-squared tests. This is June 2020, Paper 43, Question 1. Young children are learning to read using two different reading schemes, A and B. The standards achieved are measured against the national average standard achieved and classified as above average, average, or below average. For two randomly chosen groups of young children, the numbers in each category are shown in the table. Test at the 5% significance level whether standard achieved is independent of the reading scheme used. I'll begin by identifying the null and alternative hypotheses. The null hypothesis, standard is independent of reading scheme. The alternative hypothesis, standard is not independent of reading scheme. I'm working with a contingency table, so I'll begin with some subtotals for each row in each column. And these are the subtotals, including my total of 200 that I'll be working with in my analysis. My test statistic, chi-squared, is going to be the sum of all ratios of expectation minus observed, quantity squared, over expectation, and I'll now work through those calculations. I first need my expectations. These are going to come from row times column over total. That's the basis for this table on the left. So I'll describe the first calculation in detail and then post the others. For scheme A, above average, I see that the row total for above average is 50, and the column total for scheme A is 88. So I'll multiply 88 times 50, and I'll divide by the total of 200. That's going to give me a value of 22. And the similar calculations working across will be 187 over 5, 143 over 5, 28, 238 over 5, 182 over 5. These are the expected values for the table. Now in the following table I'll calculate the individual components of chi-squared, the E minus O quantity squared over E. So again, describing in detail the first calculation, the first cell, upper left corner, I have an expected value of 22, an actual value of 31. 22 minus 31 is 9. I square that for 81, and I divide by 22, 81 over 22. And similarly for the other calculations, 144 over 935, 99 over 65, 81 over 28, 72 over 595, and 1089 over 910. When I add those six values, I have my chi-squared metric, 9.569. Now for the critical value, I need to identify my degrees of freedom, which I'll note is V. I have columns minus 1, 3 minus 1, times rows minus 1, 2 minus 1, equals 2. Problem requires a 5% significance level, so I want to look up the critical value for chi-squared using degrees of freedom of 2 at 0.95, and that value is 5.991. In my comparison, 9.569, the test statistic, is greater than 5.991, the critical value. Therefore, I will reject the null hypothesis and describe what that means. Standard not independent of reading scheme. This completes the requirements for question 1.